Hello and welcome to another Marchword video. Today I want to talk about the spike protein that is part of SARS-CoV-2 and the anti-COVID vaccine and what negative effects it has on general health, but especially what negative effects it has for cancer health. This discussion is primarily interesting because of what it allows us to do therapeutically. And for that, I want to discuss at the very end of this video a story of how a friend of mine got rid of his 4 years of spike protein pathology by implementing a very, very simple regimen that I made out for him. And he's now been following this regimen for 3 months and has gotten rid of his pathology or of this persistent spike protein pathology. And he estimates that within the next month, he will be back to his former strength and sports performance from before his persistent spike protein pathology. Now, he was suffering specifically from chronic tonsillitis for these 4 years of this persistent spike protein pathology. But in cancer, it's estimated that persistent spike protein pathology can further cancer progression and cancer immune evasion and other issues with cancer that make the cancer worse to treat and lower patient survival. This makes it, of course, interesting to understand what this spike protein pathology does and also what we can do against that to at least, help in the survival of cancer patients and in helping the body deal better with cancer. Obviously, what we will discuss here is also going to improve general health. Now, if you've been infected or vaccinated, there is a chance you have persistent spike protein pathology. We're going to go over some of the symptoms just simply by discussing the causes, but I would not recommend to necessarily do such a treatment that we will talk about at the end if you are unsure whether you have spike protein. With that out of the way, I think we'll get into the video. My name is Merlin. I'm one of the co-founders of Marchwood, where we help cancer patients live longer and better lives, and we do so through coaching and implementing various, methods that are evident in research literature that have not yet been implemented in broader care, just simply because of the delay between research and care. And if you're interested to work with us, you can, of course, just hop over to marchwood.com/reclaim and book a call. The call is, of course, free, and we'll see whether we can help you. All of these things that we do are leading edge, bleeding edge. There's no guarantees with these things. So I think that is important to know as well. My background is in molecular biotechnology. I have a bachelor's in that, and I'm studying currently for my master's. So, take it as it is. If you're interested, go look. If not, disregard this. So let's talk about persistent spike protein pathology. For that, I think it's important to understand what exactly spike protein does to the body. Perhaps even before that, what spike protein is. So I'm going to draw here. This is a very, very bad drawing of a virus, but it should suffice. These virus particles usually have a genome that is somehow surrounded or associated with a kind of viral chromatin, which is virus genome associated various proteins. And then they have some sort of encapsulating membrane structure with either with capsids or without capsids. And in the case of SARS-CoV-2, this SARS-CoV-2 on the surface has cell entry receptors, which basically allow it to interface with the human body and with the cells of our body. One of these cell surface proteins is the so-called spike protein, which is called this because it kind of looks like a spike. It's kind of vaguely shaped like this, which of course, has a kind of triangular spiky shape. This spike protein interacts canonically with various receptors of the cell surface in the bloodstream. One of these receptors is ACE2 on thrombocytes, and in doing so, it promotes what is known as thromboinflammation, which is specifically a thrombocyte-derived inflammatory signal. Now, inflammation in all is an important function of the body that is usually highly regulated between various blood cells, so myeloid cells, and various more specialized immune cells, which would be the lymphoid cell lineages or would derive from lymphoid cell lineages. And inflammation is very important to the response against pathogens. It's important in allergy control. So if you have too much inflammation present with food allergens, with parts of your food that look similar to parts of yourself, you may develop allergies. Sorry, and of course, if you can't mount an inflammatory response, your immune response will also falter in the event of infection, also in the event of cancer. But then on the other hand, you also have the problem of having too much inflammation, or that it can be a problem in such things as a rheumatoid arthritis, for example, Alzheimer's, and of course, cancer. There are various ways that this chronic inflammation happens, and cancer is oftentimes related to tumor necrosis factor alpha, to interleukin 6, sometimes even interferon gamma, which usually is a good thing, interferon gamma, but can in chronic expression also lead to immune cell exhaustion, which of course is not a good thing. In Alzheimer's, it would be TREM2, which is chronically overexpressed and leads to the senescence of certain important oligodendrocytes in the brain, which then further down the line leads to a non-clearance of amyloid plaques, which then of course form these toxic plaques that then lead to exactly what we see in Alzheimer's. Does that mean that clearing up this chronic inflammation clears up Alzheimer's or clears up cancer? Well, not necessarily, because all of these diseases are multifactorial. They don't have one dimension. I mean, it would be nice if they had one dimension, right? It would be nice if all you had to do to cure cancer would be, take an anti-inflammatory drug. Sadly, that's not how it works. Cancer has various different adaptations that help it to compete against normal cells and survive in the body and actually do the damage that it does. So multifactorial are these diseases, and also so is the persistent spike protein pathology. Now, in spike protein pathology specifically, we have two kind of more complementing functions or causal factors. One is if we have a single spike protein. So this is drawn a bit differently from before, but I mean, these are structure estimates. And then these will or can, it isn't necessary in every patient, but these can very easily aggregate into multi-spike, multi-protein with different various other associated proteins, plaques, and then with like a fibrin network. Fibrin is basically what prototypically holds your blood clots together. So these spike proteins, through driving thromboinflammation, will drive blood clotting, and they will aggregate into these kind of weird non-blood clots in the blood, kind of these protein clots in the blood, that then can act essentially just like any old blood clot. And of course, this can lead to thrombosis. This can lead to embolisms, right? This can lead to, obviously, to tissue hypoxia, or rather, I should say, both of these can lead to tissue hypoxia, which is a state where the tissue does not get enough oxygen and is just depleted of oxygen and thus doesn't function properly anymore. And this hypoxia, of course, is also one of the inducive factors in cancer, specifically if you have chronic hypoxia in a tissue. The cells need to adapt precisely the metabolic characteristics that cancer cells exhibit themselves. It's not entirely known whether, it seems like hypoxia and cancer go hand in hand, right? But the causal relationship there isn't entirely known, because it's logical that if you have hypoxia, a cell needs to change its metabolism to survive. It can't use oxygen anymore as the main, the metabolism as the main fuel source or energy source. So it needs to start to ferment. That is what we see in the Warburg effect. And also in glutaminolysis within cancers, is that these cancers will start to ferment. And of course, this fermentation will then breed an environment that is more acidic, that has certain compounds in that environment that are also associated with cancer and that seem to drive certain factors or certain behaviors of cancer cells. That does not mean that, because that is one explanation of how hypoxia and cancer relate, that is the only explanation, because it's just as legitimate to say that no, the hypoxia actually isn't the driving factor or the initiating factor of cancer. We first have a separate pathology or pathogenesis where these cancers develops, and they then form big tumors. And of course, these big tumors will push away surrounding tissue, which of course also includes blood vessels, and will then become hypoxic because of this growing tumor, which doesn't have access to blood vessels or isn't invasculated, which then leads to hypoxia in this tumor, but thus hypoxia not being a causal factor or a primary causal factor for cancer, but more of a kind of down the line supporting characteristic that is caused by cancer development, but also further progressive cancer development. We don't know in what direction this causality works. So again, for spike protein pathology and its effect on cancer, this could be a very important thing. It could also be that it doesn't really matter. But I would just be on the safe side, especially because of the other effects that we will see that this spike protein has. Now, besides just having these direct thromboses or causing these embolisms by having these spike protein or, plaques that are formed by various proteins, of course, we can also just get blood clotting because of this thromboinflammation and because spike protein, also singular spike protein, initiates the thrombotic cascade. So this also initiates or promotes blood clotting, which is not good because we obviously want blood clotting when we have wounds and when we start to bleed. We want to stop bleeding. That is important. We also don't want to have our blood clot overly much because of all the problems that gives, because that will cut off circulation in certain tissues, that will give us thromboses, that will give us embolisms. So not a good idea to have overly much blood clotting. We'll get into what that means for our treatment later and different kind of treatment approaches and the validity of the various approaches. Another thing that happens from this spike protein, and we don't know exactly the signaling of this, is that spike protein seems to impair autophagy. Autophagy is a process of cell internal recycling of damaged material. And of course, cells have a lot of damaged materials, and impairing the repair of that damaged material, depending on how you look at it, can help cancer cells or basically not help cancer cells specifically, but worsen the patient outcome or improve the patient outcome depending on the level of autophagy. So, for example, it seems to be the case that cancers can prolong their survival, cancer cells, that is, prolong their survival by inducing autophagy, but also that if autophagy gets heavily induced, that these cancer cells will then die of autophagy cell death. Basically, they just go into a kind of tailspin because of so many damaged components and will then die due to this autophagy overinduction. So impairing that autophagy would deprive cancer cells or our body of killing cancer cells through autophagic induction. Now, is that going to be a significant thing in cancer care? Who knows? But I think getting all these negative effects of spike protein for general health out of the way would be a very good thing for cancer as well. Another thing it does, and this is not so much important for cancer necessarily, but more so for Alzheimer's or other neural diseases, is that it impairs the function of the blood-brain barrier, BBB. And that is not good because that means that when you get toxins in your blood that aren't supposed to be in your brain and that the liver is trying to filter out, if the blood-brain barrier doesn't work properly, then these toxins will filter into the brain and will damage neurons. And this can lead to neural inflammation. Neural inflammation has been linked, and again, causation, etc. is difficult, but it has been linked to depression, to anxiety disorders, I think even to schizophrenia. Don't quote me on that one. But we see that it is generally not good to have neural inflammation because it means that the brain can't work as it's supposed to work in a healthy individual, but is disturbed by this inflammation, which can lead to functional negative impacts. There's a few other things, of course, that spike protein does. It also impairs, and I'm going to run through them a bit quicker. It also impairs mitochondrial function. This is bad because mitochondria are already impaired in cancer cells. And we can go two ways in cancer. We can either reconstitute mitochondria to enable mitochondria to initiate apoptosis from within the cancer cells and thus kill the cancer cells. Or we can go the other direction and basically overload mitochondria and damage mitochondria further, which would not be a problem in healthy cells who have active recycling pathways like autophagy and have certain, quality of mitochondria within them, but then would disproportionately affect cancer cells. Now, both of these approaches, of course, would work. The problem, of course, is if normal cells also don't have access to autophagy, it's questionable, or this selectivity of impairing mitochondrial function for cancer cells seems to kind of fall by the wayside, which is not a good idea. For female health, There's, of course, the problem that it disrupts estrogen signaling. Now, this also has an effect in men, of course, but it's more so the effect is outsized in women. And then we also see that there are various disruptions, not just by neural inflammation, by the impairment of blood-brain barrier function, but also by direct interference with motor nerves and automatic nerves, so motor and autonomous systems, nervous systems, which means that, for example, this is something I suffered from that vanished when I started the treatment that my friend also did, that I kind of developed for him and then tried myself, because I looked at the symptoms I had and found that, well, actually interference of motor and autonomous nerves, I can't speak English, would fit my symptom profile, because I had suffered from 2 concussions in line of training, one in kickboxing, one in wrestling, doesn't really matter. I then developed dysautonomia afterwards, and dysautonomia is a dysregulation of the autonomous nervous system. Basically, I was constantly in a fight or flight state. I was sweating all the time. I couldn't sleep. My heart beat at like 120 BPM when I sat still. Not all the time, obviously, but there was heavy dysregulation in the autonomous nervous system. And that, as time progressed from these concussions, we had the injury event, time progressed. The concussion, or the after effects of the concussion, of course, lessened. Dysautonomia became better, but it never vanished. And it was always there, kind of impairing my sleep. I stopped dreaming, all of these negative effects. And then I implemented treatment we'll talk about. And then, it actually cleared up, and I now do dream and I sleep way better. I simply don't have those moments where I'm sitting still in a chair with a pulse of 120. So that is really nice. It goes beyond just cancer, what we do here. And another thing that is important for cancer specifically is immune senescence. So these spike proteins will also, along various signaling pathways, induce the senescence of immune cells. And that is really, really bad for cancer, because immune cells can kill cancer cells. Now, granted, tumors are usually not very efficiently immune surveilled, right? So I'm going to take a new page for those who don't know it. Basically, if this is a tumor, and let's say we have a blood vessel that runs around it, right? What we will see very, very early in tumor development is that we have the invasion into the tumor of various immune cells. So let's say this is a macrophage. Let's say this is a T cell, and let's say this is I guess this is a monocyte and this is a macrophage. Doesn't really matter. We have the invasion of these immune cells, and this cancer tumor will gain a population of immune cells that are largely senescent. Senescent means they don't function properly. And even though they are senescent or largely senescent, they will still do things to stop or curtail or slow tumor progression. This also depends on specifically what cell type this is and what kind of inflammatory environment this tumor has and how efficient this is. And what will happen if we have system-wide immune senescence is that this invasion of new immune cells, as the old ones in the tumor die, won't happen as properly anymore, as regularly. So these influxes of immune cells die. Now, even though the immune cells, when they are in the tumor, aren't very effective at doing their job, they still are doing a job. So there has been reports of what is called tumor cancer in younger and younger patients ever since the COVID-19 pandemic. Again, the causality here is not known, but we know that spike protein can cause immune senescence. And there seems to be a trend of increasing progression speed in cancer as a disease within patients, at least in some, I guess, anecdotal data or some empirical data. And I think that combination should be enough for us to want to get rid of spike protein. And of course, at this point, I will also tell you that you can, again, get help for this from us. I don't think you will need help, to be honest, to implement these things. These are very, very simple fixes that we did for myself, actually, my whole family, and also my friend. But you can get help at marshall.com/reclaim. And with that, I think we'll move on to, the fixing of this issue. Because, cool, we now talked about what this spike protein does and why we would want to get rid of it. But all of that is kind of, it just gives you stress. If I just told you, the spike protein does all of these negative things that are killing you, that are damaging you, that are damaging your body, that are suppressing your immune system, your healthy function, decreases the likelihood of or interferes with cancer therapies, and then just left it at that, I think that would be a pretty bad video. I think it would, just stress you and wouldn't give you any solutions. So what can we do? I think it's actually relatively known. I don't think it's used much in classical medicine, just simply because it's not patented. It's not that expensive to make. This is a compound known as natto kinase. Now, what is natto kinase, you ask? Natto kinase is a kinase from natto. Natto is a Japanese traditional dish that is basically just soybeans fermented with Bacillus subtilis, which is a bacterium, and this will give you a slimy mass of kind of fermented soybeans. It's not a paste. It's actually, you can still see the soybeans, but then it's like there's this slimy network of biofilm and half dissolved soybeans and all of that. It doesn't look very appetizing. I've actually never tried it. And maybe you should. You can look it up. Natto. It's either written like this or like this, depending on how you write it. Anyway, natto kinase is a kinase, so that is a specific enzyme, specifically an enzyme that phosphorylates or that adds phosphate groups to other proteins or actually other compounds. And this natto kinase is produced by subtilis, Bacillus subtilis, and we can extract that relatively easily and package that into pills, so you don't need to eat the actual natto, but can actually just take a pill. And this natto kinase, what this does is a few things for us. Firstly, it digests fibrin directly, which, if we go back to this image here, these strands here are fibrin, if you remember. So by digesting these directly, we will improve this process of deaggregating the spike protein and these plaques, and at least get singular spike protein. What then do we do with the singular spike protein? Well, natto kinase has also been shown to digest directly this spike protein. So that's nice. Now, both of these attributes have been shown in vitro, right? In vitro means in a petri dish. So we have a petri dish where we have in vitro usually it's growth tubes, but let's say we have a petri dish. Very, very classical. We have some solution in there, and then we drip natto kinase in there, and then we see that natto kinase in there, and then we see that this natto kinase does both of these things, right? That would be in vitro results. That's not terribly useful for you because you're not a petri dish, you're a living organism. So the question is, how do we deliver this natto kinase into your bloodstream so that you can actually have the benefits of natto kinase, digesting both this single spike protein and these amyloid or these spike protein amyloid plaques. So let's get back to natto kinase. If we want to have this in your bloodstream, we need to understand whether we can just, take a pill or take, this natto and eat it. Is that enough? Is it enough to eat? Interestingly, yes. So we know from other studies in vivo that natto kinase can have blood thinning properties in vivo, in humans, specifically in humans, which means that, and this is from oral natto kinase. So if you take a pill, for example, that has natto extract, which will have natto kinase in it, you can take that orally, and that oral pill will be blood thinning in you, which means that the natto kinase actually does get into your body, which means that it will unfold these effects. And it will apparently unfold these quite drastically, because if it is blood thinning, this means it is actively digesting fibrin as it comes from this oral dose into your bloodstream, which also will mean that it will digest the spike protein. So first order of business, of course, is to take natto kinase. This is what I did. This is what my friend did. This is what my entire family is doing. If you want to learn more about that, you can go to our archive at marchworth.com and then look for the article. I will also have a link to the article in the description so that you can just check there, specifically for the natto kinase dosing. And we will also keep that article up to date if dosing requirements or dosing recommendations change, and if I now say the dosing in this video and it changes in half a year and we amend the article, then I would have to remake the video or kind of put a comment underneath the video, but then you watch the video and don't see the comment, and then this is bad news. So just go to the article. The article has all the information you need to implement it actually. And as you will see in the article, I also list out other things that can help with the clearance of spike protein, because we established now that nattokinase does actually go from the stomach, as prototypical stomach, kind of ugly stomach, but goes from this, well, technically from the gut, but it doesn't really matter, into the bloodstream. And then it unfolds its effects. We don't know whether it enters cells. So we don't know whether it into our cells, because we also have cell internal spike protein, from infections or vaccinations or what have you not. So we don't know whether nattokinase can enter cells and then have it unfold its effect there. So how do we get rid of cell internal spike protein? Well, I would say the solution to that is autophagy. As I've already stated, autophagy is a kind of cell internal recycling mechanism or process where components of the cell that are damaged, foreign, or defective are put into their own little compartment called the autophagosome. Very, very creative naming. And then they are digested there, and their constituent components, usually amino acids and lipids, are then released back into the cell for, to fuel further processes and metabolic requirements, etc. Now, I also stated that spike protein inhibits this autophagy. So now the thing that fixes spike protein pathology is also directly inhibited by spike protein pathology, which puts us before kind of conundrum. And that, of course, is how do we boost autophagy so that this inhibition here doesn't matter? And there are various ways of this, of course. I have written in the article that autophagy can be boosted by fasting. It can also be boosted, but less so by ketosis. And these are kind of lifestyle or nutrition interventions. But then also autophagy can be induced by various supplements or various pharmaceuticals, I should say, because they're sold as supplements. They're not licensed as pharmaceuticals. They don't have patents on them. They're not, in any way considered dangerous because they're so safe. So your doctor doesn't need to prescribe them, but they have pharmaceutical effects, if that makes sense. Maybe we can kind of take the term soft pharmaceutical instead of pharmaceutical outright. And one such example of a pharmaceutical or of a compound or extract that will induce autophagy is extract of the fungi Cordyceps sinensis, which is a Chinese mushroom that parasitically infects caterpillars and can be ground up into powder and then taken in pill form or powder form and has various effects in our body. One of these is the induction of autophagy. Now, there's also recently come to my attention a few other things that can induce autophagy. One of the more potent ones of these is spermidine and resveratrol, which are quite potent autophagy inductors. I have not yet amended the article. As I'm recording this video, I have not amended the article to include spermidine and resveratrol, but I will probably, before I've uploaded this video, amend it to include those two options for autophagic induction. Now, I would recommend to use a combination, to use either fasting and cordyceps or fasting and spermidine and fasting and resveratrol. And again, if you want to know how to do that, go to the archive, look for the article on spike protein, or go down into the description and actually just go with the direct link. And obviously, again, if you want help with implementing this, you can get our help at marchworth.com/reclaim. You can, of course, also get at that point much more help with implementing anti-cancer strategies more broadly. These are supportive to classical care. They are not alternative to classical care. They're integrative models of an integrative method of just improving your life, make your life better, make your life longer, perhaps, cure you along the way. This is probably never going to happen, cure of cancer. I'm just saying that. But, there can be hope. We can definitely help you live longer and better, statistically speaking, which I'm going to put in a caveat here because a lot of people misunderstand statistics. And that is that some of these things that we implement with patients have in the past in other populations or in cancer patient populations increased survival duration and curative rate, or basically rate of complete disease remission. Now, we can presume that pattern will pattern will continue in the future, and that future patients who implement the same methods will also live longer and have a higher chance of complete disease remission and will have better lives. Statistics sadly doesn't work that way. Just because we can draw statistical conclusions about the past does not mean that we can necessarily predict stochastic events in the future. This is a general shortfall of this. Take it as it is. In the past, it's helped people live longer in research papers, etc., in actually published research. Not just me saying that. You can actually look at the research. We have it on the website. Again, we have it. Not sure whether it's in the archive. It's probably just on the Mosaic page, marchworth.com/mosaic. So doesn't mean just because it worked in the past that it will work for you, but we can at least help you implement these things in your life to hopefully get you healthier, get you living better and longer. And of course, specifically, we can also help you implement these anti-persistent spike protein pathology measures that I have implemented myself, that our family has implemented, and of course, that a friend of mine has implemented. And I talked about the story of my friend. Basically, what he went through is that for 4 years, he had chronic tonsillitis, which is basically a chronic inflammation of the tonsils with a kind of chronic sinus infections, because of course tonsils are kind of a immune reservoir for the upper respiratory airways, which includes the sinuses. This means, of course, if that reservoir is constantly inflamed, the immune cells therein will get senescent, they will stop functioning. It's kind of the same process as in cancer tumors, or a similar process, not exactly the same, but similar process. And then they won't function properly. This immune reservoir won't protect the sinuses and the upper respiratory area from infections. And thus he had like throat infections, sinus infections, nose infections, all of that for 4 years straight. He couldn't do sports basically at all, especially towards the end of those 4 years. It got progressively worse. At the end, he just gave up sports because he was basically constantly sick. He was even bedridden at times. So it got really, really bad. It got so bad that classical care physicians wanted to remove his tonsils, and he is my age, 25. Removing tonsils in such a young patient to me seems idiotic if you can fix it other ways. Now, obviously, these classical care physicians didn't know another way to fix it, and it's a very, very standard procedure to perform a tonsillectomy if you have chronic inflammation of these tonsils. I don't think it's a good intervention, but that is what is done. When he came to me with that news that, he was considering removing his tonsils, I asked him to go out on a limb with me and trust me for a month, allow me to look into the research literature with chronic tonsillitis, see what the causes are for that, and find him a non-invasive solution to his problem. I then went into the literature. I looked, for various causes of tonsillitis, and then found that, okay, spike protein is one of the causes. And this friend, he has been vaccinated once and has also had multiple infections with SARS-CoV-2. So, looking at that, you would kind of expect him to have a decent spike protein load, and thus also be exposed to persistent spike protein pathology. And then I said, okay, I don't know if that is a problem, but we can try a regimen, which is exactly what I've shown here, Natto kinase plus autophagy induction, to get rid of this spike protein and hopefully get you back on track. He said, all right, I'll try it. Better than surgery. At least it's worth a try, especially it's non-invasive, it's not dangerous, etc. And then he did that. And now 3 months later, he is back to doing sports twice a day. He has had, pneumonia shortly in December last year, but then that was resolved. Probably wasn't full-on pneumonia, but was some other respiratory infection. But he's back to twice a day sports. He's back to almost his peak strength before those 4 years of this persistent spike protein pathology. And honestly, I'm kind of blown away. It's phenomenal. I can't say it in no other way. It's just phenomenal to see that he's doing better. And, I hope that this method that we discussed today will do the same for you in general health, but also specifically in cancer health. And again, the offer that if you want help, you can reach out to us. Reaching out doesn't cost anything. Asking us doesn't cost anything. And you can see whether we're full of shit, whether we might actually be able to help you. And if you want to learn more in general about what we do, what we found in research, etc., you can go and look at marchworth.com/archive, where you can find all of our posts. With that all said, I hope this has been interesting. I hope this has been an interesting look at the effects of spike protein and at how we can ameliorate those effects by clearing spike protein both cell externally with nattokinase and cell internally with autophagy induction. With that out of the way, my name is Merlin, and it's been great.